Nah, I reject pink. Green. Go to the middle one and right. Right.
What color do you like to use other than pink? What color did you think was better than pink?
Chocolate.
That's
Okay, so 20 and 6 are both divisible by two, so
I don't like that color. Yeah.
it comes out as 10 and 3. Then what do I do with x3 and x5?
You take the x3 and you take the other.
It's kind of like 3 minus 5 is -2. That just means there's 2 on the bottom. And then the y's. Go. All right. Do we still have an A so far?
Yeah.
Already failed. Okay, what can we do on number 2? Right. What's different between 1 and 2? 1 is just one term on top and bottom, so you just start canceling. This is 2 terms you have to factor. You can take out what? 3A. There's take stuff out, square minus the square, and 3-term factor. You gotta know. Be able to recognize, always check first, can I take stuff out?
Why are you taking that?
If because you can. If I divide both terms by 3A, what I'm left with is A plus 2B. Okay, and then on the bottom, what? And if I take out a 4, I'm left with A plus 2B. Basically, if nothing cancels out, you did something wrong. A plus 2B's, yeah. Bye-bye. So it's just 3A over 4. If the 3 and 4 are reduced, you would need to reduce that. In this case, they don't. All right, are we good? Okay, number 3, this is 3-term factoring, so I know it should look something like this. Okay, what multiplies into -28 that adds up to -3? And what multiplies into -8 that adds up to 2? So, what's different about number 4? It's a multiply problem. So, even though there's 2 different fractions, you can kind of treat it like one. Anything on top can reduce with anything on bottom. Because when you multiply the top and bottom, it's just go together. So, for example, 8 and 2 reduce to 4 and 1.
Well,
B and B squared just leaves a B on the bottom. A and A cubed takes 1A out and leaves 2 on the bottom. So what do we have left on top? On bottom, a squared and b. All right, do we still have an A so far? Hopefully. All right, number 5, multiply again. Just a lot of stuff on this one. Yeah, I don't remember.
Let's see.
I don't think you heard it. Dylan.
Did you just say he?
How do you know it was an thing?
I think he was okay. I believe
He's done.
More? All right, what goes into 12 that adds up to 7? 3 and 4. What goes into negative? Uh-oh. That might make us very warm.
the heat.
Probably.
Prevail.
I hope it's not, but it might be. This might get toasty. All right, what multiplies into negative 3 that adds up to 2? 3 minus 1. What multiplies into 6 that adds up to negative 7? And this is a square minus a square, right? So, because something squared equals these. What times what equals x squared? X and x, what goes into negative 16 or negative 4?
Yeah, I didn't. I added. So
And we just kind of go crazy with the stuff and get crazy in that class. It's good.
this is actually Mr. Jordan's all getting in the days.
I don't think so.
Why not? Please. He did.
What's different about number 6? Okay, it's division, which means you have to flip the second one. I'm gonna flip it over here on the right. I can squeeze it on the page. Oh, that's tick stuff in it.
We got it. Oh. You did it. Only 2 times.
Okay. Great.
We made it ourselves.
Good job. Okay, what goes into x squared? X and x. What goes into negative 6 y squared? What goes into negative 6 that adds up to 1? 3 and negative 2. But since it's 6y squared, we have to put 3y and negative 2y. Okay, and on the bottom, x and x again. What multiplies into negative 15 that adds up to negative 2? Ready? What multiplies into negative 15 that adds up to negative 2? Right, except for it's 3y and negative 5y. Okay. What?
So why do you have all the extra X and Y's in there? Is that
Are you talking about here or here?
there?
You just, if it ends with y squared, you just add a y.
That's all it is?
Yeah, okay. Why did I only put one parentheses over here on the right? Because all you can do is take something out. What comes out of the, oh, actually I need to flip it. What comes out of this one? 9. And if I take a 9 out, I'm left with x minus 5y. What comes out of the top one? 3x. Notice I flipped it, and then what's left is x minus 2y. What cancels out? X minus 2y's, x minus 5, lots of stuff. X minus 5y's, x plus 3y's, anything else? 9 over 3 becomes 3. So it's 3 over x. That one was like 14 on the chapter review. Do you guys recognize that one? Yep. Yeah. I can test.
Good. You can shoot at the mark.
Speaking of tests, is there any way you could tell us what's possibly might be very novel to say?
Oh. Thanks. Where's the test? You mean it says?
Yeah.
I think Chapman's learning, but there's
That will be.
there's surprise.
It's here.
Going up to the dump. Visit the Bartlesville City Dump. Seen it. Okay, so what else do you mean? Please come on full. So what do we need to do first, you guys think? Listen, boys. Hey, Dylan, Trevor. I said Trevor, I meant Tigger. Your names are too simple.
Yeah.
What are we gonna do first, you guys think, for this one? Okay, you should factor first, see what they're made of, and then see, and that helps you figure out what they both go into. If I take out an 8, I get x plus 3. If I take out a 6, I get x plus 3.
You just divide that thing?
Yes, basically, that's how you take out. Candy. Put it away.
Hello.
Okay. If, what do these two both go into? What do 6 and 8 both go into? No, that's what goes into them. What do they go into? What are the multiples of 6 and 8? Common. Okay, 24. They both go into 24. What does the x plus 3 and x plus 3 go into? X plus 3. So this is the common multiple. The reason they ask this is it's like a warm up to finding common denominator. What do 8 and 6 both multiply into? 24. What do the x plus 3's multiply into? X plus 3. Yeah, you gotta kind of see what they're made of to see what they go into. What do 8 and 6 both go into? Like, what's the common multiples of 8 and 6? So 6, the multiples of 6, are those multiples of 8.
You're just trying to find the smallest one.
Yeah. LCM stands for least common multiple, so the smallest thing. It's not a.
Go with it.
Yes, but that would not be I'd have to take the point off because that's not the least. Okay. So 8 is an adding problem. What do we need on addition? Common denominator. Shh. Are these denominators the same? No, but they are related. You guys remember this one? They are. Okay, if you take a negative out of the bottom, it would become -5 plus n, right? If you take a negative out of both those, which is the same thing as n minus 5, if you switch the order, which is the same as that. So these two are opposites. If you take a negative out of this one, you can turn it into n minus 5. So they are common denominators now, after I took the negative out. So instead of doing 7 plus 4, though, we have to do 7 plus -4, basically. So it's just 3 over n minus 5. N 5 minus n is the opposite of n minus 5, which basically means if you take a negative out, you can turn it into n minus 5. 5 minus n.
So if you make it,
Yes.
so
Okay, number set 9 was like a more common problem in that chapter. What is the common denominator going to be?
A plus 3.
A plus 3, a minus 5.
the answer.
Okay, so what is this denominator, Miss?
So like finger and claw.
Oh, yeah. What is this fraction missing? A minus 5. So that means the top gets an a minus 5 too. What's this denominator missing?
A.
A plus 3. That means the top gets an a plus 3. Common denominator is a plus 3, a minus 5. Whatever the denominator is missing, you have to multiply it in. So we basically just need to simplify the numerators here. 7a times a minus 5 is 7a squared minus 35a plus 4a squared plus 12a. We can add our like terms together. 11a squared, negative 35 plus 12 is negative 23. Okay, we don't really need the top. You could take an a out. That doesn't, it's not going to help you in this case. It won't reduce with anything. So you can just leave it like that. Yeah.
So on the top, okay, so on the bottom, you just take whichever on the left and multiply to the right, whichever on the right, multiply to the left.
On this problem, that's basically what I'm doing.
So why do you do that? It's not on every problem.
No, quite.
On other problems, what would you do?
You find the common multiple,
Which is
find the common denominator. These both go into basically just one.
okay. Why did you know to take a minus 5 on the left and not on the right?
This denominator was missing a minus 5 from the common denominator. So if you multiply the bottom by something, you have to multiply the top by the same thing. Same thing with the a plus 3 is over here. Okay, what is the easiest way to solve number 10? Cross multiply is the easiest way. But number 11 is like number 22 that you guys asked me about at the beginning of class. Very similar, isn't it? I wonder, did I copy it? Or did I make, I think I made it up, actually. I tried to make it up, but I think I kind of copied the. You could. It'd probably be A little easier to just get rid of the fractions first. Okay, so if you cross multiply, you get 7 times x plus 4 equals 4 times x plus 13. Then you got a basic algebra problem after that. You got x's on both sides, you need to subtract them off one side. Sorry, I'm getting sloppy, I'm trying to hurry here. Okay, there was something we were supposed to, you probably don't, hopefully at this point you already knew what to do. Remember when we're solving equations like this, the answer might make the denominator 0 and you have to throw those away if they do. That might happen. I don't really remember if the test does or not. I kind of made these up, so. So on 11, it's kind of like 22. What do we do on 22? What do these denominators all go into? What do 15 and 10 both go into? 30. So multiply everything by 30 and x. The reason we do that is because those will reduce with the denominators. 30 divided by 15. Maybe I did. Did I copy this one? A little bit different, isn't it? I thought I made it up.
Oh, so
Maybe I just slightly changed it. Okay, I don't remember. I reduced with the denominator. Multiplied it for x. What 10 and 15 go into is 30.
Start.
Okay, a little bit trickier. Find the common denominator on this. Not much trickier, but how do we find what all these denominators go into? The middle denominator looks factorable, doesn't it? And guess what it factors to? What goes into -4 that adds up to -3? Which, what a coincidence, that is the same as our other denominators. So, what do I need to multiply everything by? Right. What everything goes into, x minus 4, x plus 1. Gonna be a lot of work to clean up. All right. Because now all our denominators will cancel out, right? That goes away. Those two both go away. And that goes away.
Question. How many problems?
It's like 20. So what we're left with is x plus 2 times x plus 1 equals 30. I'm just looking up here. Plus 4 times x minus 4. The more of these steps you get right, the more points I can give you. And if you get the whole problem right, I'll give you 100.
Stay here for a second.
Can't stay very long. I have to watch the video during the time. 11 minutes. How do I solve an x squared problem?
You put all of the like marks there. So it's 16.
Yeah, 30 minus 16 is 14. So I'm going to minus 14 and minus 4. Move everything to one side. Okay, that factor's done that. Goes into negative 12, multiplies into negative 12, that adds up to negative 1. Okay, what x values would make these factors equal 0? Does that screw up any of our denominators? 4 is a no-no, negative 1's a no-no, so we gotta get rid of the 4.
How did you get x plus 3x plus 2?
I foiled this.
Foiled?
Yeah. Alright. Sorry I'm going a bit fast, but we gotta make sure we're getting kind of close. Okay, 13. This could be an easy one if you know how to do it. What are the asymptotes? There is a vertical asymptote, it's going to be called x equals, and a horizontal, it's going to be called y equals. Yeah, it's where they don't actually touch. Well, maybe you could graph it and then try to figure out where they are, but how can I tell just by looking at this where they are? Okay, yeah, the vertical asymptote is what makes the denominator 0 because you can't divide by 0. So that's why nothing is happening when x equals negative 2. That's the vertical asymptote. The horizontal asymptote is y equals, yeah, basically this number out here. Because the graph's just up 3, so there's nothing going to be happening at y equals 3.
So the denominator, the asymptote is just what you make negative. This is what you use to make a negative on bottom.
Yes.
So if it was just, if it was plus 3, you just make a negative 3.
Yeah. Yeah, or you guys might remember like the plus 2 shifts the graph left 2, and the plus 3 makes the graph go up 3. So that's kind of related to those also. Think of it that way. How did we graph this thing?
Did you agree?
Okay, the middle of the graph is x equals negative 2. So remember I had you guys choose x values that were close. I'm not going to count it wrong if you choose different x values, but your picture might not look right.
Then you apply.
Yeah, just plug those in. So if I plug in negative 4, I get negative 2, 1/2, 3.5. I plug in negative 3, I get 4, negative 2.5, I get negative 2, 5.
We only learned it 20.
So negative 1.5. Negative 1. It's negative. I think there's 19 on this. Negative 4, 3.5. 3, 4. Negative 1.5. These. Remember they always had a couple curves, something like that. If you graph it correctly and do 13 correctly, your answer should match. X equals negative 2, see how there's nothing happening right there? and then y equals 3. There's nothing happening right there.
So is the final answer just the graph? There's no like.
Or to the graph, yes. Okay, I will leave the direct inverse stuff on the board. So is 15 direct inverse or joint variation? Oh, we're doing, okay, I guess we're not doing too bad.
Correct.
Well, because it could actually.
Okay, remember that K, what did K stand for? It's the constant. So in this case, 15 looks like, is like this one. So it is direct. And then what is the constant of variation? 7. And then how about this one? Volume equals 1/3 base times height. Yeah. If there's three variables, it's got to be joint. And the constant is 1/3.
Are you gonna leave the?
Yeah. Okay. And then a couple problems left. Or wait. Oh, I only put 18 on there. Wonder what I didn't put that was on the test.
David just fell.
No, we didn't hear it though. Yeah.
Sure isn't very important, is it?
Yes,
Can you open the door? Scared.
yes.
You got it. You thought that you looked at it, you did it, and I know. I guarantee David looked at all those two.
They probably just go like,
You think I'm looking?
okay, if A is inversely proportional to B, B is 6 when A is 4, find B when A is 3. How do we set these up? Okay, inversely, this one. X times Y equals X times Y, or in this case, B times A, or A times B equals A times B. We're gonna make it. I think we're gonna make it. I think I can. I think I can. You guys read that book when you're little?
I'm not sure that's it.
It's like the power of positive thinking. It's new age.
Me.
Yeah.
Yeah.
How did they? I mean, there is some truth to it. If you think you have a chance of doing it, you're a lot likelier to try.
They were.
They had made them think that they would be better, so they did get better, something like that.
Oh, well, it's called, I'm talking about the placebo effect.
I think so.
It's like if you give people something they think's a drug to help them and it's not real, sometimes they still feel better.
You're like riding a bike. Your body, your brain thinks I'm not gonna drive off, but then your body like has like an urge to or something.
Okay. X varies directly. If you look over there, it says X over Y equals X over Y. So it's 12 over 45 equal 32 Y. Just make sure if you put X on top over here, you put X on top here.
Why?
You can put Y on.
You can put Y on top as well. Doesn't matter because either way you're cross multiplying. So you get 12Y equals whatever 45 times 40.
And why?
120. All right. You guys ace it? No, there are other possibilities. Let's aim for at least a B.